Welcome back to our video module on dynamics. Today, we'd like to revisit our merry-go-round problem. We're going to keep a lot of this information on here, but we're going to revisit our merry-go-round problem, and instead of looking at position, we're going to look at velocity. And we're going to ask the same questions. Mainly, what is the difference between what you see being a passenger on the merry-go-round and what your friend sees in the absolute frame? Assuming, of course, that we have some sort of angular velocity on the merry-go-round. Today, we're going to look at the relationship between a rigid body and the velocity seen of a particular particle in the absolute frame. You probably already know that if we wanted to know the speed of this particle, let's say the particle p, s for speed, is simply the angular velocity times the distance from the center, so omega r. However, we want to look at this maybe a little bit more carefully. We now need a direction, and that's going to be our velocity. We know that the velocity is equal to the angular velocity crossed with the position vector. Or if we wanted to be maybe more careful, we'd say the velocity of point P with respect to O being the stationary frame of reference, is equal to the angular velocity crossed with the position of point P with respect to O. What does this really mean? This means that if you are on the merry-go-round, you're looking at this point, nothing's happening. The point's just stuck on the merry-go-round. It's just sitting there, so there is no velocity. However, if you're on the absolute frame, you're seeing this point P go around you and around you and around you, and the velocity is in the tangential direction at all times. So this gives us a feel for the difference between how things look on the rigid body, how things look on the primed coordinate frame, and how they look from the absolute frame. So in other words, it tells us the relationship between a fixed particle on a rotating coordinate frame and the velocity that particle has in an absolute frame. Another way that we can see this mathematically is what is the velocity of point P with respect to O? That is the derivative of the position of point P with respect to O with respect to time. That equals omega cross position with respect to O. So in other words, if we wanted to know the derivative of this value right here, if we wanted to know the derivative of some position, we would take omega crossed with that position. This is an interesting fact that'll come up again and again as we move forward. So in summary, we've taken a simple fact that we've known before, mainly the speed is equal to omega r, and we've extended that a little bit more carefully to get this equation. Another way to see this is we look at this coordinate frame right here, and what are we really seeing? We're seeing the primed coordinate frame in red is rotating about the fixed coordinate frame, and as it rotates, the point P is going to have this velocity, some tangential velocity in the fixed frame. I hope this gives you a more fundamental feel of velocity in a rotating rigid body. In our next video module, we'll take on acceleration.